So what identifies an atom as being a particular element is the number of protons. The number of protons stays the same. The electrons are on the outside of the atom. The protons are in the nucleus. They're at the core, the center of the atom. So I think of the nucleus, those protons, as being your personality, your soul, and the electrons are the stuff on the outside. That's more like your appearance or the clothing that you wear. You can change how you look to other people, right? You could disguise yourself as a famous person. Does it make you that famous person? No, but you could look like them, right? So atoms can change the numbers of electrons. They can gain electrons or lose electrons, and that affects how they look to other elements, to other atoms, but it doesn't change the number of protons that they have deep in their heart, right, in their nucleus. So if you gain or lose electrons, electrons have charge. They're negative. The proton, the number of protons stays the same. That's where the positive charge is. So if you're losing electrons, then overall this atom's going to have a positive charge. If you're gaining extra negative electrons, then now overall it's going to have a negative charge. So a positive anion is called a cation. A negative anion is called an anion. I'm sorry, negative ion. Yeah, don't use the word in its definition. A positive ion is a cation. A negative ion is an anion. And so there's another pair of things that correlate. You have to figure out how to remember. I like cats. I have positive feelings for cats. And so positive and cat go together in my mind. If you hate cats, that's not going to work for you. You'll have to figure out something else. If we look at these words, anion has an extra N in it, and that's the negative one. That might help. So when we have an ion, we have a charge. And we show that charge as a superscript on the upper right side of the element symbol. When we write ion charges, we do it a little differently than exponents in math, because we don't want them to be mistaken for exponents. So we write the magnitude of the charge first and the sign afterwards. So let's look at lithium. In many reactions, lithium atoms will lose one electron. So we start with a lithium atom, a reaction occurs, and lithium gets separated from one of its electrons. It has lost a negative charge. So it started out with 3 protons and 3 electrons. And now it lost one, so it has 3 protons and 2 electrons. 3 positive charges, 2 negative charges. So overall, that ion has a positive 1 charge. So when we write the symbol for the ion, we indicate the charge as a superscript. Now, chemists don't like to write the number 1. So we don't write the number 1, we just write the charge. So lithium plus. What the charge is depends on how many electrons were lost and whether they were gained, how many electrons were involved and whether we lost them or gained them. Fluorine, oh dear. Okay, I fixed the slide. Fluorine atoms gain 1 electron when they undergo reactions. So here, a fluorine atom, that's the symbol for fluorine. We add 1 electron to it. Now it has an extra negative charge. So it becomes a fluorine ion, and we write the sign. We don't write the 1 because we don't write 1s unless we have to in chemistry. So fluorine started out with 9 protons and 9 electrons. That makes it neutral. It gained an electron, so now it's got 10 electrons. That means it has 10 negative charges and 9 positive charges. So those add up to being a -1 charge. Any questions? Electrons are squirrely and pesky in many ways, and one of the ways is that they have a negative charge, and adding and subtracting negatives just kind of makes you squint sometimes. Determine the charge of each ion. So a nickel ion that has 26 electrons. To figure out what the charge is, we need to know how many protons there are. And that information is on the periodic table. So nickel is element number 28. That means it has 28 protons. So we've got 28 protons and 26 electrons. So the electrons have negative charges. So if I have 28 positives and 26 negatives, what's the overall charge? Plus 2, right? It's positive 2. So if we were going to write the symbol, which it doesn't specifically ask us to do, we'd write Ni 2 plus. In math, you wouldn't write the plus, and if you did, you'd put it before the 2. We're trying to be different, okay? So the charge sign is always written, and if the magnitude is other than 1, we also write it before the sign. That didn't come up very well. Okay, bromine. How many protons does bromine have? 35, because its atomic number is 35. It's number 35 in the periodic table. It is just that simple. Find it on the periodic table, the number above, number of protons. So that's 35 positive charges. We are told here that we have 36 electrons. Those are negative. What's the overall charge? -1, right? So when we write the symbol, we take the element symbol, Br, and the charge becomes a superscript. We don't like to write the number 1, so we just put a negative. How about a phosphorus ion with 18 electrons? It's got 15 protons and 18 electrons. So what's the overall charge? -3. I've got 15 positives and 18 negatives. Overall, that's -3. So the element symbol for phosphorus is a capital P, and then I'm going to write this as 3 minus. Questions? I will not try to trick you with the sign being before or after. I could inadvertently trick you on an exam. I've done that before. But I won't purposely trick you. There are some things I will try to trick you with, but I'll warn you about it first. What if we're given the symbol for the ion and then find the number of protons and electrons? So here, an S2 minus ion, it says find the number of protons and electrons. Well, how do we figure out how many protons? We look at the periodic table. So sulfur has how many protons? 16 protons, because it's element 16. That's the only reason. And so we need to know how many electrons there are, and we know that the overall charge is 2 minus 2. So there must be 18 electrons, right? Yeah, you can make an equation and subtract and stuff, but you're probably better off just trying to think about it, right? If I've got 16 positives and overall it's -2, that must mean I have 2 more negatives than I have positive. So 18 electrons. Any questions? There are some things in chemistry that are hard, and there are some things that are simple. So don't make the simple things more difficult, okay? So the number associated with the letter A for the main group elements, those group numbers that I like, 1A, 2A, 3A through 8A, those give us the number of valence electrons for the elements in that column. So we're going to learn more about how the electrons are structured, but for now, just think of the valence electrons as being the outermost electrons in the atom. There's the valence electrons, those are the ones on the outside, and then there's the core electrons. Sort of like, you know, your jacket and your boots would be your outerwear, and then there's your underwear, right? Your panties or briefs or whatever. So taking off your jacket or putting on a jacket, we do that a lot. But you don't go around taking off your underwear a lot during the day. That's, you know, your core, that's like, nah, I need this, right? So the valence electrons are in the outside. Those are the ones that can change easily. So what we find is that main group elements tend to form ions that have the same number of valence electrons as the nearest noble gas. So how many valence electrons do the noble gases have? What group are they in? 8. So It turns out that having 8 valence electrons is energetically a very stable, a low energy place. That's like not real meaningful to students. So I have this crazy place I call Mrs. K's Chemistry Land. Disneyland's the happiest place on earth. Chemistry Land is maybe not the happiest place on earth for students, but I like it. And so I've personified in my mind a lot of these things, made atoms be more like people, because then it helps me to make sense of what's going on. So I think of the noble gases with their 8 valence electrons as being those kids in high school that had it all together, right? They were popular, they wore just the right clothes, they got invited to all the right parties, right? And everybody wanted to be like them. And some people tried to be like them by dressing like them. They weren't fooling anybody, were they? But they still dressed like the popular kids. When my oldest was in high school, Hollister hoodies were the thing, zippered sweatshirt from Hollister. And so you drive by campus, you see all these guys walking around, they're all wearing their Hollister hoodies. So the noble gases with their 8 valence electrons, that's what all the other atoms are trying to be like. So they don't have 8 valence electrons, but they're going to gain or lose them so that they do. So maybe they need to take off some electrons, or maybe they need to put on electrons to be like a noble gas. Doesn't make them a noble gas, but then they look like them. So look at these halogens. They are in group 7A. How many valence electrons do they have? 7. So they need to gain 1 electron to have 8. So they form -1 ions by gaining 1 electron. So when fluorine, if we look on the periodic table on the wall, fluorine atoms have 9 protons and 9 electrons. If it gains 1, it has 10 electrons. What element has 10 electrons? Neon. So when fluorine puts on 1 more electron, it looks like neon. It doesn't become neon because the number of protons doesn't change, but it looks like neon. And chlorine will add an electron to look like argon. Bromine will add an electron to look like krypton. Over here, oxygen has 6 valence electrons. So to become like the noble gas with 8, it has to gain 2. So oxygen, sulfur, selenium, and tellurium form -2 ions. They gain 2 electrons so they can have 8. Here's nitrogen. Well, there he is. How many valence electrons does nitrogen have? 5. So how many does it need to gain to get 8? 3. So if it gains 8 negative charges, it's going to have a 3- charge. What about phosphorus? Same thing. So phosphorus will tend to form a -3 ion.
Is it like that all the way down?
It is like this for the nonmetals. Nonmetals gain electrons. Nonmetals form negative ions. The metals don't do that. So let's go over here and maybe look at sodium. How many electrons does sodium have? Well, sodium on the periodic table, element number 11. So it has 11 protons, 11 electrons, right? It's a little harder at this point in the semester to explain why losing 1 electron would be great for sodium. So electrons, this is really simplifying things, and reminds me of the movie Shrek, okay? Atoms are like onions. And the electrons are in layers like the layers of an onion skin. So you peel off a layer, and what's underneath? Another layer. So sodium, how many valence electrons does sodium have? 1 valence electron. It has a total of 11 electrons. It has 1 valence electron. So that's just like a little part of an onion skin on the outside. If we peel off that part layer, underneath is this nice complete onion skin. We take off 1 electron. Now sodium has 10 electrons, just like neon. Sodium wants to look like neon. Okay? So it's going to lose an electron, and that gives it its positive charge. That happens with all of these alkali metals. They have 1 electron. they lose that to become like the previous noble gas, the nearest noble gas. Now, sodium with 1 valence electron could gain 7 electrons to get 8 valence electrons. But, I mean, just kind of common sense. Easier to lose 1 or gain 7? Losing 1 is easier. So metals tend to lose electrons. So the group 1A lose 1 electron, form a +1 ion. The group 2A have 2 valence electrons. They lose both of them to form a +2 ion. And then we can jump over here and look at aluminum. How many valence electrons does aluminum have? It's in group 3. It's got 3 valence electrons. It's going to lose those 3 valence electrons. So when it loses 1 electron, now it has the same number of electrons as magnesium. Loses another one, it has the same as sodium. Loses 1 more, and it becomes like neon. Okay? So we can predict the charges of main group elements by their position on the periodic table. Group 1A form +1, group 2A form +2, group 3A form +3. Metals form positive ions. The non-metals form negative ions. So there's different ways of remembering this. Choose the way that you like the best. You can take the group number and subtract 8. 7 minus 8 is -1. 5 minus 8 is -3, if you like that. You can think about, well, how many electrons would this need to gain to have 8? Or you can pretend you're playing a weird board game. And this is the starting place over here. And you, like if we're doing nitrogen, we start here. And we're going to count backwards. -1, -2, -3. And that's going to predict the charge. We can do that down here. This would be 0, -1, -2. Yes?
Will we apply this to determine whether or not a chemical reaction is likely?
We're not going to go into predicting really whether a chemical reaction is likely. We'll be able to predict precipitation reactions, but that actually doesn't have anything to do with the electrons. Those sorts of things can be predicted, but it's pretty complicated and beyond the scope of Chem 3A. Okay, so based on their position in the periodic table, what ions do potassium and selenium tend to form? Well, you need the element symbol first. Potassium is what? K. So we find K. What group is it in? It's an alkali metal. It's in group 1A. It's going to lose an electron and form a +1 ion. So main group metals, the charge they have is the same as their group number. Potassium's in group 1. It has a 1 positive ion. Selenium is Se. Find that on the periodic table. Most students like to count backwards from the noble gas. If you start at krypton is 0, bromine's -1, selenium's -2. So 2 minus is the charge on selenium. Any questions? This is important. Yes?
I don't understand how you got the negative.
Okay, that's a very valid question. So the way I did this is I just looked at the periodic table. Let's draw a little piece of it. So here's selenium, and here's bromine, and here's krypton. So one method is to look at the noble gases. The noble gases are like the nobles of Europe. They just don't interact with the common people, right? They're off snooty by themselves. They're all self-satisfied. So chromium's not going to make any ions. He's just 0. He's neutral. He's cool by himself. So one way to predict this charge is pretend that this is 0, and we're counting backwards, so it's negative. So this would be -1. This would be -2. So that's one way. The other way, look at what group number is selenium in? It's in group 6A, or 16. Both of these have the 6, though. How many electrons does it need to get 8 valence electrons? It needs 2. So if it gains 2 negatively charged electrons, it'll have a charge of -2. Okay, any other questions? Yes?
Would elements always undergo a reaction, or can they just stay?
Whether an element undergoes a reaction or not depends on energy changes. If it's energetically favorable, it will generally undergo a reaction. If not, it won't.